Yeah, if you want to know what the modern trends for 2021, you can look at 2010, right? If you go back 11 years, maybe even 15 years, those were the things, right? Those were the patterns. This is around the time the 12-factor app manifesto came out from Heroku. There's this concept of what a stateless app was, how you should be thinking about app configuration, how you should think about when your app would just suddenly crash right when the cloud came out, maybe 2008, some people a little later, 2012, 2014. And then during that time, you were getting ephemeral instances. There was no automatic failover. There was no live migration in the cloud. So you had to focus on resiliency. So these have been kind of the patterns that were required if you wanted to be able to leverage a hyperscaler, AKA a cloud provider. CI/CD goes back another 10 years, 15 years before that. So 25 years ago, some people were talking about this idea that you should be able to have a system that can compile and ship your software. So those are the same patterns, it turns out. Very similar patterns that we have today. So to your question is, what is Google doing to make it easier? Number one, tools like Kubernetes was a way to say, how do you do that? The biggest challenge is you would read about these things. You knew some people were doing these things. Kubernetes is how you do those things. So of course, we've open sourced that project 8 years ago. We have a commercial offering, GKE, Google's Kubernetes engine. And recently we announced Autopilot or Auto GKE. And what the important part about Autopilot is, even though Kubernetes gives you all the tools to deal with like containerization, auto scaling, vertical auto scaling, horizontal auto scaling, there was still a lot of infrastructure there. And so one big feedback we've heard over the last 4 years is that I don't want to manage a Kubernetes cluster. Even if Google is doing all of the management with something like our Kubernetes engine, there was still this concept of like, how many nodes do I need in my node pool? What should they look like? How do I think about scaling? So what we've done is taken a lot of that experience and said, how do we make that disappear and still give you what you consider a Kubernetes API? So AutoGK is that thing. On the app level, of course, there's patterns like gRPC. I just read a great post from the Dropbox engineering team, how they're leveraging gRPC to move from this idea of monoliths versus microservices, and now just start talking about functionality that is exposing simple interfaces like gRPC. These cloud native patterns, we've tried to roll it at the app tier, gRPC, service mesh, Istio. You'll hear about Anthos a little later on. And then things like Kubernetes to bring it all together at the infrastructure point. And the last thing I'm going to say about this is that once you have these modern platforms, the thing that most people miss, we're now fully declaring everything from the load balancer to the application to our network policies, that now we can actually wrap entire policies across the entire infrastructure. Some people will notice this through Open Policy Agent. There's a component called Gatekeeper. This is the big game changer on the security front now that we have these quote unquote modern tools to hang our policies on. My guidance is you just got to stop with the strategies. To be honest, you're not going to ever be done. Whatever plan you have right now, things will be somewhat different 3 years from now. And I think a lot of people fall into this trap, right? When mainframes were super hot, people had a mainframe strategy. They bought a bunch of mainframes. They coded all the way to the mainframe without thinking how the world would look like 10 years later. Now, you don't want to over-engineer things trying to future-proof everything, but you got to understand that the software is never going to be done, ever. So I think what we have to do is get out of these big, lofty checkpoints and saying, hey, we're going to modern. No, you're not. I think the number one thing is, what happened to cause your organization to start neglecting its software? Right? If you buy a new car and you don't do any maintenance, the car's going to fall apart. And you could sit back and say, you know what? I know we haven't serviced this car in 5 years. It's making weird noises. This year, we're going to transform the car by taking it to get maintenance. That's neglect. What most people need to look at is, am I on my latest version of my runtime? For example, there are a lot of customers who will say, hey, Kelsey, we have legacy software. And I'll ask them, what makes it legacy? oh, we're running .NET from Microsoft and it's old and we haven't upgraded in a long time, and we're using the patterns that were great ideas 15 years ago. What should we do? My concrete guidance would be, number one, get to the latest version of .NET, right? It used to be called .NET Core. They renamed .NET Core to .NET 5. What that means is if you can get your software to the latest version of .NET 5, notice I didn't say switch languages. I didn't say move to Node.js. I didn't say rewrite it into Java. I didn't say any of that. I said pragmatically get to the latest version of .NET. And guess what that means? .NET now supports Linux, Windows, and Mac. So that way the whole container world opens up to you if you want to manage your applications that way. So for the most things that I'm guiding customers to do is say, hey, let's stop neglecting the software. Health checks have always been important. Metrics and logging has always been important. Updated software has always been important. Turns out, if you do those things, you'll be eligible to take advantage of platforms that expect you have done that. So that is the pragmatic advice that I give customers. No more strategies, just discipline, and let's not abandon our software. I mean, it depends on what you're actually trying to do and how much history you have, right? Because in the organization that I worked in, they had a 70-year history. They had a lot of mainframe. They were IBM's biggest customer at one point. So they did a lot on the mainframe. Still today, a lot of banks still using mainframe, nothing wrong with that platform. But that platform means a certain thing. You're going to have to run where the mainframe sits. And so when you look at these different ideas like machine learning, you look at all these new capabilities in the world, everything can't be done on the mainframe. So now how hard is it for you to interface with these new technologies and keep some of the stuff that you already have? This becomes the biggest challenge. So maybe you can't move too far away from the mainframe. So you need a cloud region in the same region with the direct peering, so that way networking doesn't get in your way. When you think about most of the apps, so the thing that I think helped a lot of the enterprises, especially in the financial sector, there was a big movement to adopt a lot of Java technologies. And even though people didn't consciously make this decision, it kept their app pretty portable. The JVM fits well inside of a container. The JVM fits well in a VM or even bare metal. So from that choice, that sector was able to re-platform on the underlying technology, whether it's Kubernetes or Linux in the cloud, from that one choice. I think that has been one pattern. And I think there's regulations around security. So there's a little bit more discipline in the financial sector to at least know somewhat what's going on, how data is flowing. And that helps them understand the value of something like Kubernetes. If I told them that they can start to enforce security policies in real time because of the Kubernetes API, they see the value in that because they already understand that that's a requirement. Some verticals don't have that. Some verticals are like, well, we never really thought about that because we just run on-prem, we don't believe we're a target, and we don't have regulators asking us for that. So I think the financial sector, the biggest challenge for them is they have lots of the best practices over the years from all of the vendors. And now, yet again, there's a new way of doing things. They can't just go delete everything else. So for me, I think most of the financial sector is they're trying to move as fast as they can because profit margins are slim. Right? A lot of the retail banking, there's no more commissions on stock trades. So a lot of the margins has gone away. So that means you can no longer get away with the way you were doing it because you got to figure out how to be competitive. So they're adopting things as rapidly as possible. And last thing I'll say here is, it turns out most of the financial institutions were already building their own Kubernetes-like thing, right? If you look at how they were doing things, they were trying to build their own little distributed systems. They were already building these kind of things to regulate data and how it's being used. So when these things get standardized, you'll typically see financial institutions say, oh, we get it. That's what we've been trying to build. So seeing something like Kubernetes come out and it being standardized, they know what they're getting, so they're more likely to adopt. You know what's funny? When I think about the web, when I started, there was AOL. We used to have CDs with 50 hours trial. You put the CD in, you can get online. And then there was Netscape, right? That was a big revolution. I was no longer locked into this AOL walled garden. And I now had this thing called Netscape, and I can explore the whole web. Things were just blinking at me back then. And then we got all this proprietary stuff, right? We started getting things like Macromedia Flash, where you can have these interactive sites, but everyone had to agree to use Macromedia's product. Some sites supported Flash, some didn't. And it was pretty terrible for accessibility and battery life. And then I remember, you had other browsers like Firefox and all these things came out to challenge Internet Explorer and things like that. And then Chrome came out. And Google said, we think the future of the web must be based on standards like JavaScript, CSS. And people were like, oh, you guys are crazy. How are you going to build a video game using open standards? And we were like, well, we'll be patient, but it has to be possible. And I remember when people had things like HTML5 and all the things you can do to rebuild applications in an open and standards way without having Javalets and servlets and all this other stuff. GCP is very similar. At the early parts of cloud, people was like, this is just a continuation of proprietary systems. Every cloud provider was basically saying, here's our proprietary take on what was going on, because at the time, until OpenStack, really, all infrastructure is just going to be proprietary. You just got to figure out who you're going to pay. And so Google's stance was just like that Chrome experience. Google said, wait a minute, this doesn't scale. Trying to support every proprietary system, at that point, we're just going to be a hosting provider if the world will continue down this path. And also from our internal experience, you can do a lot with things like containers. You can do a lot with just standards like around networking, but we have to put APIs on top. So there was a case where Google used to do a lot of white papers. So a lot of people got introduced to Google technologies through like the Go programming language, a lot of the cloud native tools, Prometheus for metrics. A lot of these other tools are built in Go. So a lot of people were introduced to Google Cloud technologies just as a standard practitioner. And then when we saw containers come out, what did we see? A bunch of proprietary platforms. And so when Google came out, we did what we normally do. We write white papers, we explained the concepts, and then we did something a little different during the cloud era. We said, hey, let's introduce Kubernetes to the world, and let's have a managed service around it. When we think about big data, let's have things like Beam. Let's support that API and protocol directly. When we think about our SQL products, let's support standard SQL as much as possible and maybe layer value on top of that. But we worked really, really hard to adopt industry standards, and when they were lacking, we will go create them. Think about Istio. Think about when we think about observability, a lot of those things, not to take credit away from the large ecosystem of people creating and expanding, but a lot of these come from white papers of the way Google thought about the world. And so when we put out all these industry standards, and this is where you've grown and you found success, when it's time to pick a cloud provider, and one says, hey, not only did we invent Kubernetes, we know how to run it for you. We know where things are going, right? Not just what the status quo is. We know where things need to go next. And I think that's why when people have a choice and they get to evaluate them all and touch it with their own hands, not only does it feel familiar, you feel like you're on the right side of where technology is going.